Hello students, here is an example to help you understand the binomial probability distribution. Suppose we want to observe the number of heads from 10 flips of a particularly strange coin. Empirical data shows that the heads come up 68% of the time on the strange coin. We want to explain how this experiment satisfies the 4 requirements of a binomial experiment. The first thing we're going to look at is this experiment repeated a fixed number of times? The answer is yes, because as you can see here, we have 10 flips. So because it's performed 10 times, it is performed a fixed number of times. The trials in this experiment are independent, meaning the first flip is not going to affect the outcome of the second flip. And the events of getting heads is mutually exclusive from the event of getting tails. So the events are mutually exclusive and they can't happen at the same time. The last requirement is each trial has the same probability of occurring, which is true. And given in this question, each trial has 68% chance of getting heads. So all of the requirements are covered, and this is indeed a binomial experiment. The question says here, what is success in this experiment and what is failure? By reading this, suppose we want to observe the number of heads. So that is success, is the number of heads that we see. If we get a head, that is a success. What is a failure? Not getting a head, which is tails. Tails is going to be the failure in this experiment. Next, we want to find n and p. N is the number of trials, which is 10. So I have n is equal to 10 here. P is the probability of success. So that is 68%. We're going to write p is equal to 0.68. We always work with decimal numbers. We don't work with the percentages. Next, we want to find the mean and the standard deviation. We have the formula over here. So the mean is equal to n times p. So I'm going to go ahead and compute the mean over here. The mean is basically equal to n, which is 10, times p, which is 0.68. So the mean is 6.8. To compute the standard deviation, I'm going to use the other formula, which says the standard deviation is the square root of n times p times 1 minus p, as you can see here. So this is basically, I say the square root first, so I'm going to say sqrt. And then I see n, so I'm going to type 10 times p, 0.68, and then times, open parentheses, I see parentheses in the formula, 1 minus p, which is 0.68, close the first parentheses for the probability of failure, close the second parentheses for the square root formula, and then click enter. I'm going to round this to 2 decimals, so I will round it to 2 decimals accuracy. The next question, we want to compute the z-score when x is equal to 6. We know to use the standardized function when it comes to computing the z-score, so we will use the standardized function. And it's asking about x. We know x is equal to 6, comma, the mean is computed previously, 6.8, comma, the standard deviation, which is computed previously as well. I'm going to close and then click enter. I will round the z-scores to 4 decimals, like so. Now, this is the biggest part of the question. We want to compute or find the probability distribution for all the possible outcomes for this experiment. Notice how we're performing this experiment 10 times and we are observing the number of heads that appear. So possibilities for the number of heads is we can get 0 heads, so we're going to write 0. We can get 1 head, so we're going to write 1. We can get 2 heads or 3 heads or 4 heads or 5 or 6 or 7 or 8 or 9 or 10. Those are all the possible outcomes for that experiment. Now let's find the probability of each of these outcomes. Well, usually we're going to use either the tree diagram or we're going to use the formula to compute this. But for Excel, we don't have to. We're going to use the binomial distribution function in order to compute that. So we're going to say this is equal to binomial.distribution, this function over here, it's asking about the numbers. So we're going to say, well, we want to compute each possibility. So the first number we have is 0. I'm going to click on the cell that has 0. Comma, next is asking about the trials. The trials are 10, so I'm going to just type in 10. And then it's asking about the probability. In this case, we're finding the probability of heads, so we're going to use the probability of success, which is 0.68. That's given in the question. Then it's asking me, do you want to accumulate these probabilities and add them up as you calculate them? And the answer is no. I don't want to. I want to compute the probability for each of these outcomes. So I'm going to say false. I'm going to choose false and then click enter. I will go to the previous cell and I will double click to populate my table. Now the first number appears in a scientific notation, which is basically when the number is very lengthy, Excel makes it into a scientific notation. This translates as 1.1259 times 10 to the negative 5 power. So 10 to the negative 5th power. This is scientific notation. And to translate it into a number that we understand, that means we're going to push the decimal to the left 5 spaces because it's negative, so it's going to go to the left. How many spaces? 5 spaces. So the number is going to be 0.12341259. So that will be the actual number. Now, we easily can answer the following questions because of the two facts that we know, that the binomial probability distribution events are independent. The trials are independent and the events are mutually exclusive. So we're going to use the addition rule and the multiplication rule without worrying about overlapping of the events. So to answer a question like, what is the probability of 5 or 6 heads? I'm going to say that is the probability of 5 heads plus the probability of 6 heads. Because it's an OR event, so I'm going to combine the two probabilities together without worrying about them happening at the same time, because those are mutually exclusive events. So this is the probability of 4 or 6 is equal to the probability of 5 plus the probability of 6. So the probability of 5 or 6 is basically the probability of 5 plus the probability of 6, which is I can compute easily from the table. The probability of 5 is this, the probability of 6 is this. So these two cells over here. So all I have to do, I'm just going to add these up. I will use the sum function to add these probabilities up. So that is the needed probability or the answer for that question. I'm going to round it. I'm going to turn it into a percentage. You can leave it as a decimal. Actually, I encourage you to leave it as a decimal. You're going to round it to 4 decimal places, or you're going to turn it into a percentage and then add 2 decimal places to that percentage. Either way. The next question says, what is the probability of at least 4 heads? At least 4 heads. Meaning either 4 or 5 or 6 or 7 or 8 or 9. The least number is 4. That means we're going to compute the probability at least 4 heads is equal to the probability of 4, 5, 6, 7, 8, 9, 10. And that is basically adding all of these numbers up. So I'm going to say the answer is going to be the sum of all of these probability. So this is an OR event, so I'm using the addition rule. And because binomial probability distribution events are mutually exclusive, I'm not going to worry about them happening at the same time or double counting. So again, I'm going to turn this into a percentage and then I'm going to add 2 decimal places to it. So as you can see here, the Excel sheet makes it very simple to compute binomial probability distributions and answer the questions. The first step that I would do is to create the table. This is going to make all the difference when you answer all of your questions. I hope this video helped you, and I will see you in a different video.